the previous class, students, we had discussed about the cathode rays origin, how the rays were originated from the cathode, and by their behavior in the electric and magnetic field, we had seen that they are consisting of negative charge. So cathode rays are nothing but they are a beam of negatively charged particles, that is electrons. And now in today's class we are going to discuss the two experiments by Millikan and Sir J.J. Thomson, who discovered the charge on the electrons and the E/m ratio, that is the specific charge on the electrons. Now first let's focus on the determination of charge on electrons. Millikan, a scientist, with the help of an oil drop experiment, he discovered the charge present on the electron, that is 1.6 into 10 to the power minus 19. Let's go for the experiment. In this, he took an atomizer, and with the help of this atomizer, a spray of oil drop was produced. So I had written the first point, spray of oil drop was produced with the help of atomizer. Okay, now one of the drop is allowed to enter the electrical condenser or an apparatus where the two charged plates are held. This is positively charged plate and this is negatively charged plate. Now the oil, one of the drop of the oil enters the electrical condenser through this small hole. Okay, this drop enters in this electrical condenser through this small hole. Okay, now the space is irradiated. The space in this electrical condenser, with the help of X-rays, this is irradiated, and these X-rays causes the ionization. जो भी गैस प्रेजेंट है वहाँ पे उसका ionization कर देती है, and जो भी वहाँ पे air है, गैस है, वहाँ पे उसका ionization कर देती है, and this oil drop absorbs 2 or more electrons. Space gets irradiated with X-rays which ionizes the molecules of the air, and this oil drop absorbs 1 or more electrons. So X-rays causes the ionization of the air, and then this oil drop absorbs 1 or more electrons. Okay, now when this oil drop absorbs 1 or more electrons, it gets a negative charge. Very important, it gets negative charge. So when this negatively charged drop, which has absorbed the electrons, now because of the gravitational force it will fall down. Okay, but now the voltage is applied on these electrical plates in such a way that this oil drop, it is made stationary because it is having negative charge, and the upper one is the positively charged plate. So the voltage is applied in such a way that this electric field, it holds the electron in the air. It becomes stationary. It balances the downward gravitational force. Okay, so applying electrical field, what it will do? It will make it stationary. Now from the magnitude of the charge applied, हमने कितना charge वहाँ पे apply किया है, mass of the droplet, उस droplet का mass कितना है, and the charge was calculated by these two values. हमने वहाँ पे कितना charge apply किया है, and what is the mass of the oil droplet, the charge on the this droplet was calculated, and it was found out that it is always a small whole number multiple of a value, that is minus 1.6 into 10 to the power minus 19. So always it is a multiple of this value. We can say the charge on an electron, the charge on a droplet was a multiple of this value, Ne. N can be any number. So the value of the charge present on the electron calculated by Millikan, it was 1.6 into 10 to the power minus 19 coulomb. Okay, and this is negative charge. This was an important discovery, and he gave us the value of the charge. Then in the next experiment, which is done by Sir J.J. Thomson, J.J. Thomson, he determined the specific charge, that is E/m ratio of electrons. In this, he took a cathode. See, this is a cathode which is connected to the negative terminal, and there is a circular anode which is connected to the positive terminal. Now cathode rays, when they originated and allowed to pass through this perforated anode, it passes. Now when it passes, we are applying the two fields. This is electrical field and this is the magnetic field. Suppose if it is an electrical field, the magnetic field they are applying in this direction. So this is y-axis and this is the x-axis, and the electrons are moving in this direction. So we can say this is the z-axis. So I had mentioned it here. It's a three-dimensional electric field. If it is in this direction, magnetic field it is in this direction. They are perpendicular to each other to the flow of the electrons. Okay. Now the deflection of the electrons. We had already said that cathode rays are nothing but a beam of fast moving electrons. So the deflection of the electrons will depend on the strength of the two fields. Okay. Now when only electric field is applied, we are not applying any magnetic field, only this electric field is applied. This negatively charged particles, they will obviously deviate towards this positively charged plane and they will get deflected at point A. This is a fluorescent material coated so that we can notice where these cathode rays are hitting. So A, it is the point where the cathode rays hit the fluorescent material or the screen when only electrical field was present. Now when only magnetic field is present, they hit at point C. Okay. In the presence of magnetic field only, they get deflected and hit at point C. In the presence of electric field only, they get deflected at point A. Now suitably balancing the two fields, electric field and the magnetic field, the electron was allowed to hit at point B. Actually point B वही point है, अगर आप यहाँ पे electric और magnetic field नहीं लगाओगे तो in the absence of this it will goes directly at this point. Okay, so by suitably balancing the two fields, they hit at the point B. Now with this experiment, he just made different variations. He took different discharge tubes, he took different materials of the cathodes and anodes, then he took different gases. But every time the ratio of E by M, that is specific charge, was coming out to be the same, and it was 1.76 into 10 to the power coulomb per kg. Okay, so this is a universal value. We can say electron is a part of every atom. It is always constant. And with the help of this E by M ratio and the charge, the mass of the electron was calculated. Mass is equals to E upon E by M. The charge was this 1.6 into 10 to the power minus 19 E by M ratio. Here, from here the value is taken, and the mass of electron was calculated as 9.1 into 10 to the power minus 31 kg. Okay, so with the help of these two experiments, students, the charge and mass as well as E by M ratio was calculated. So now in the next I will tell you about the various points about the electrons. We will summarize all the features of the electrons. That's all for today.